Hello, my name is Micah Scheibel, and I'll be telling you today about our work on photon-stimulated desorption of magnesium sulfide and the formation of a sulfur exosphere at Mercury. Sulfur has previously been detected at Mercury as an ion in the FIPS instrument of the MESSENGER mission. However, current exosphere formation models underestimate the amount of sulfur liberated from the surface. These previous models considered only ion sputtering as a source of sulfur, and the current work tests photon-stimulated desorption as an additional source. The experiments in this study used magnesium sulfide and exposed it to 193 nanometer photons to eject the material from the surface. Then, using a second laser pulse, we did Rempe characterization and detection of the desorbed sulfur neutrals. The signal here shows that we see predominantly sulfur in our signal with small contributions from other ions that are formed non-resonantly, meaning not by the Rempe process. By varying the delay time between the two laser pulses, we are able to map out a velocity distribution, which we found is well fit by a bimodal Maxwellian consisting of a low temperature thermal component and a high temperature superthermal component. By integrating over this curve, we can then determine what is the cross-section for desorption of a sulfur neutral. And we can see here that these cross-sections are on the order of 10 to the minus 22 centimeters squared. Then, using those measured cross-sections, we can estimate what are the neutral densities of sulfur above the surface of Mercury. Here we show the neutral density on the left-hand side, both at perihelion and aphelion, which decreases from a maximum of around 10,000 neutral molecules per square centimeter at the surface at perihelion, or 3,500 for aphelion, down to effectively very, very small amounts. In order to better compare these results with the FIPS measurements from Mercury, we also calculated, using a constant photoionization rate, the cumulative ion flux both at perihelion and aphelion. These measurements confirm that PSD should be considered as a source term for sulfur when modeling the exosphere formation at Mercury.